This is our last of our GCSE further maths trig videos. We're just going to be looking at a few examples where we have to adjust the range. So we're going to jump straight to these questions, straight to the examples, and see how we get on with them. Okay, the first example says solve sine 4x is equal to minus 0.1 for 0 is less than or equal to x is less than 90, giving your answers to 2 decimal places. So I'm going to work beyond 2 decimal places here in my answer, in my working here, just because I'm going to have to use my working out to get the final answer. So just so I'm not losing accuracy, I'm going to go to 3 decimal places. So first thing I'm going to do is my basic angle. So basic angle is sine to the minus 1 of, instead of minus 0.1, I'm just putting in 0.1. And when I did this, I got 5.792. This was on 0 was less than or equal to x is less than or equal to 90. But our angle isn't x as it had been in the previous examples. Our angle is 4x. So this bit here, this x has to multiply by 4 to give you 4x. That means your 0 also multiplies by 4, which is still 0. But more importantly, your 90 multiplies by 4, so it's 360 degrees. So instead of us just looking for answer between 0 and 90, we have to look for answers between 0 and 360 degrees. So we're on to our cast diagram. We're on to our cast diagram, C, A, S, and T. And again, I'll just mark on that 0, 90, 180, 270, and 360. And we have to look at this full turn. Now, our original sine was negative. So sine is negative in here and in here. So I'm going to mark on my angle, which was 5.792. Squeeze that in, 5.792. And my first angle is going to be round to here. My second angle is going to be all the way around to here. So, and this is important, this bit, it's 4x. My angle was 4x. 4x then is equal to 185.792 degrees. And 4x is also equal to 354. 354 point, sorry, 1 second. Okay, so this example says solve sine 4x equals minus 0.1 for naught is less than or equal to x is less than or equal to 90 degrees, giving your answer to 2 decimal places. So it says giving an answer to 2 decimal places. I'm actually going to work the 4 decimal places here. So the first thing I'm going to say is my basic angle. My basic angle is equal to sine to the minus 1 of 0.1. And if I do that, I'm going to get 5.7392. And that was for 0 is less than or equal to x is less than or equal to 90. Now notice my angle is 4x. So I have to double this x to be 4x. That means, sorry, I have to multiply my x by 4 to give you 4x. Then I have to multiply my 0 by 4 to give you 0. And 90 by 4 to give you 360 degrees. So I'm actually going between 0 and 360 degrees instead of between 0 and 90 just. So we're on to our cast diagram now. I'm going to do a decent sized cast diagram as it's going to be awkward to mark in my angle because it's quite a long looking angle. And I'm going in here and in here. So that means my 5.7392 degrees goes in here and my 5.7392 degrees goes in here. Why it goes in the C and the T is because the sine is negative in these quadrants. So I've got my 0 degrees, my 90 degrees, my 180 degrees, my 270 degrees, and back to the start. This is back full turn, so this is 360 degrees. So my first angle is all the way around to here. My second angle is all the way around to here. So that's what you've got for your two angles. So I'm going to omit the working out for my two angles in. And remember, this is what 4x, the angle was 4x. 4x is 185.7392 degrees, or it was 360 degrees minus a 5.7392, which is going to be 354.2608 degrees. Then your last thing to do is to divide through by the 4. Remember, your answer's only got to be to 2 decimal places. So 46.43 degrees or it's going to be, let me just check this one, sorry, it was 354.2608 divided by 4, which is 88.57 degrees, and they're both to 2 decimal places. Okay, next example, it says solve tan of 10x is equal to 3.2 for minus 18 degrees is less than or equal to x is less than 18, giving our answer to 1 dp. So I'm going to work to 3 dp's here just to be sure I'm getting this right. Okay, my basic angle then is going to be equal to tan to the minus 1 of 3.2. So my basic angle works out to be 72, let me just check this, tan to the minus 1 of 3.2 equals, and I think I said there are 3 decimal places I would go to, so it's going to be 72.646 degrees. Okay, we're good to go with our cast diagram. Decent sized cast diagram again. You have an awkward looking angle to draw on it. So its tan is positive, so it's going to be in here, and tan's positive, so it's going to be in here. So 72.646 degrees goes in here, and 72.646 degrees goes in here. So 0, 90, 180. Oh, I don't know if anyone has spotted this mistake here. It's not a mistake at all. I forgot to change my range. It was minus 18 is less than or equal to x is less than or equal to 18. So then that gets multiplied by 10 because our angle was 10x. So that goes up to 180 and minus 180. So your range, we've done the 0, the 90, 180, go back the way, minus 90 and minus 180. So my first angle is dead easy. My second angle is a wee bit trickier to find, but not for the likes of us. So we'll have 10xn is equal to 72.646, and the other angle is going to be, and it's going to be minus 107.354. And then your last thing to do is just divide through by 10, and remember, give your answer to one decimal place, I should say. So it's going to be 7.3 degrees, and then it's going to be minus 10.7 degrees, and they're both to 1 decimal place. So just have a look, folks, at this last thing. Your 2 answers, are they in the range that they've been given? They are. They're both between minus 18 and positive 18, so they make sense. So if you've got something here, say I've got 20 degrees and I got minus 100 degrees, I know I've gone wrong because I'm not within my original range. Okay, next example says solve cos of brackets x minus 10 is equal to 0.8. So first thing get is your basic angle, so that's cos the minus 1 of 0.8, and that got me a basic angle of 36.8699. I've gone to 4 decimal places because they said to go to 2 decimal places. Okay, what I have done is, that was on for my angle, which was x, but my angle really is x minus 10. So it's very important in this case. That means you've got to do your 0 minus 10, which is minus 10, and your 360 minus 10, which is 350. Quite often it doesn't make a difference, but you'll see, the odd time you'll see why. We'll wait until that happens to explain that. Okay, draw your axes, your cast diagram. You still label your diagram as you would, the 0, the 90, the 180, 270 and 260, but 360, but you're also going to be going back the way as well, so that's maybe why some people don't like to label this bit. Where your angle is going to be, cos is positive, so cos is going to be in here, and cos is also going to be in here. The 36.8699 goes in here, 36.8699 goes in here. Sorry, that's the A and the C quadrant, I should have said. And okay, the first one's dead easy. It's just the positive one. The next one, you've got to really figure out, would this be the negative one? We can only go backwards back as far as a -10. So this is going to be outside our negative range. So actually to get to this one, it is still going the positive way. So it is 36.8699 short of 360 degrees. So my answers, x minus 10, remember, this is what our angle is equal to 36.8699 degrees, or it's going to be, and that's going to be 320. Apologies, not too sure what happened there. So we have, first, we'll go through that again. Our x minus 10, this was our angle, remember. X minus 10 was equal to the first one, which is 36.8699 degrees. And the next one is, to get this one, it's 360 minus the 36.8699, which worked out to be 323.1301. Your last thing to do is to bring that 10 across, minus 10 across, and it adds to give you 46.8699 degrees and 333.1301 degrees. And then I should have given my answers to two decimal places, so 46.87 degrees and 333.13 degrees, and they're both now to two decimal places. Okay, next example, solve tan of brackets x plus 20 for is equal to 0.1 for 0 to 360. First thing is your basic angle is tan to minus 1 of 0.1. When I did this, I got 5.711. I'm just going to check that. Tan to minus 1 of 0.1 is equal to, yes, 5.711. I've gone to 3 decimal places here because I'm working to 1 decimal place. So just keep my accuracy right. And this was on x, 0 to x is less than 0 is less than or equal to x is less than 360. So if I change that middle thing to x plus 20, that goes up to 380, and that 0 goes up to 20. So that's what we've got so far. You now have to do your cast diagram. C, A, S, and T, and this really is why I'm not overly fond of labeling my axes, because this one you're going all the way around. It's a bit strange to have things labeled. I'm just going to label my 0, and that's all I'm going to label, and we know how this thing works now. So we've got our angle, which is 5.711 degrees, doesn't look like it here, and our angle, which is 5.711 degrees, and they're both, it's in the A and the T because tan's positive. And the first one, we are allowed to go all the way around to 380 degrees. So the first one I'm going to come to would be 5.711 degrees. Now 5.711 isn't in our range, so it hasn't worked. So this is important for us to understand. This thing has been pushed out of our range because we have adjusted it. If something gets pushed out of our range, then something else will be brought into it. So what I mean by that is going to be the first one doesn't work. The second one is going to be fine. So our first answer is x plus 20 degrees could be equal to 185.711 is absolutely fine. The next one we come to is a full turn plus another 5.711. So it's 365.711 degrees. So we'll just make a wee note of that. That's a full turn plus 5.711 degrees. That's where that has come from. Almost your last step to do is bring the 20 across and subtract, which gives you 165.711 degrees. And over here, it's going to give you 345.71 degrees. So your answer to 1DP, 165.7 degrees and 345.7 degrees, and they're both to 1 decimal place. Now on this, folks, just have a look again, be very critical and think, is this within my original range? Your original range was 0 to 360, and our answers are 165.7, 345.7, so happy days, they're both within your original range. It looks good. Okay, 2 more examples to go. This one says solve sine of 2x plus 30 is equal to 0.34, and as per minus 90 is less than or equal to x is less than 90. First thing is your basic angle. I'm going to go through this one as quickly as I can. So that's sine to the minus 1 of 0.34. And when I did that, I got 19.8769. Go on to 4 decimal places because I want 2 decimal places. Now this was for minus 90 is less than x is less than 90. So if I multiply that by everything by 2 and then add 30, this will change. So multiply 90 by 2 gives you 180. Add 30, gives you 210 degrees. Multiply minus 90 by 2 gives you minus 180. And then add 30 gives you minus 150 degrees. So that's what you've got. So if you do your cast diagram, and again, all I'm going to label is my 0, and I'm just going to mark on my angle. So sine is positive, so it's going to be in here and in here. So that's going to be 19.8769 and 19.8769. And my first angle I'm going to come to, so I'm allowed, my range is from minus 1 is all the way around to minus 150, which is going to be around here. None of my angles are going to be in this one, so that's fine. And all the way around to positive 210. So in actual fact, we're grand. We don't have to worry about this. Both of my angles are going in the positive direction. So I'm going this way, and I'm going this way. So my 2 angles, so remember it's 2x plus 30 is going to be equal to 19.8769 degrees, and take 19.8769 away from 180, you're going to get 160.1231 degrees. Then do a wee bit of working out, take the 30 away first, you're going to get minus 10.1231 degrees, and for this one you're going to get 130.1231 degrees, and your last step then is just divide through by 2, you're going to get minus 5.06155, and over here you're going to get 65.06155, and then I have to do these to 2 decimal places, so minus 5.06 degrees, and this one's going to be 65.06 degrees, and that's the 2 decimal places. Okay, our last example, we had to solve cos of brackets 1/3 x plus 15 is equal to 0.91. First step is your basic angle, cos to the minus 1 of 0.91, and that is going to be equal to 24. Let's just check that, sorry, shift cos to the minus 1, cos to the minus 1 of, and it was 0.91 is equal to 24.495. It's going to be the 3 decimal places, and then we'll have a look at what's going on here. So we had 0 is less than x, less than or equal to x is less than or equal to 1080, I should say. So 1/3 x plus 15. So multiply your 0 by 1/3 and then add 15, gives you just 15. And then multiply 1080 by 1/3 and then add 15 is going to give you 375 degrees. Okay, cast diagram time. Draw your cast diagram. Do it a decent size so you can mark on your angle. Okay, so you've got your cast diagram, just mark on the 0, that will do. And then cos is positive, so your 24.495 goes in here. And it's also cos is positive in here, so 24.495 goes in here. So if you have a look at this one, our range is from 15 to 275, so this works, this is absolutely fine, as is this one. So it's pretty easy. So 1/3 x plus 15 is equal to 24.495 degrees, and it's also equal to 335.505 degrees. So then it's just a linear equation from here on in. So take the 15 across and take it away from both of those, and we'll see what we get. Okay, so when we take the 15 away from both of those, what you get is 9.495 degrees, and the other one I got 320.505 degrees. My last thing to do is divide across by the 1/3, or you could say the same as multiplying by 3 is the same as dividing across by 1/3. So if you multiply both of those by 3, you'll get 28.5 degrees. That's to one decimal place. And the other one you're going to get, you're going to get 961.515 degrees. And that's it done. That's the end of our GCSE Furlerman's Trig videos. You're now able to do the following questions. So it's exercise 4D if you're Trig workbook, and it's questions 1 to 10.